Hey, welcome back. This is part 2 of the lesson. Now we're going to get into a little more of the analysis besides making the graph. The fourth step on this is to find the correlation coefficient. And then we're going to build a function, whether it's linear, exponential, or whatnot. We're going to plot that model into the graph and then see how well the model compares to the original data set. So if I'm looking at my data here, I've got a graph. Let me just kind of move it out of the way. And if you don't know much about spreadsheets, Excel, or Google Sheets, it's really easy to manipulate things as long as you select the right thing. I know sometimes sorting data can be a bit of a pain, but when you sort things, for example, I can make sure you highlight everything, including the headers. This top row up here are called headers. So you can do things like data, sort range. My data has a header row, and I'm going to sort it by inches of precipitation or something like that. A to Z, Z to A, whatever. Kind of different ideas. That's important when you do analysis too, because you can look at certain things. Again, I want to go back the way I was, put everything in order of time, highlight everything, and then data, sort range, header rows, and then we're going to start by year. Awesome. What I want to do here too as well is I'm going to highlight row 1 and 2, and you see I'm not grabbing here in A, but actually off to the side, and then I'm going to right click and insert to above. I'm just going to give myself some space because I need to put in some more information, including this correlation coefficient. Okie dokie. In fact, I'm going to actually, the other things, I don't even need this start date and end date anymore. Mean and inches of precipitation are the same thing. I'm just going to delete that stuff right now. Boom, gone. Just to try to make things look a little cleaner. Records, I'm going to leave that for a second. It's the number of data points we had up to a certain point. Here's where I'm going. Correlation. Correlation coefficient, you probably learned this back in Algebra 2, is the letter R. And it represents how well the data fits. We've been focused on this too, kind of a bit of a review. I'm just going to give it a label, correlation. And then right here in cell B2, I'm going to type equals. Equals is how you program things in Excel or Google Sheets in a spreadsheet. And the command to do the calculation is called correl. Correl, there it is. Pearson product moment correlation coefficient. Aha. Whenever you use a formula, that equal sign means it's a formula. It's like hidden stuff inside the cell you're working in. It says data Y, comma, data X. And so the Y data in this is the precipitation, and then the X is the year, 1 through whatever. So this is a little bit in my way. I'm going to just hide this real quick. So I'm going to grab my Ys. Don't include the header. Make sure you get just the data, and I can hold down Shift and Control and the down arrow to get everything, comma, and then the X's are going to be those, and close parentheses, and boom, I get a correlation coefficient of negative 0.31. So it is really low, number one, so it's not a really good fit. But two, it's also negative. You'll notice that matches my line over here because it has a negative slope. And so, of course, it has to have a negative correlation coefficient as well. Make sure, in my little write-up, in my little shared document or whatever, I would include that. So, found the correlation coefficient. Build a function for the data in the form. If it's exponential, here's some instructions on how to do it. If it's linear, you're going to use commands like slope and intercept. And let me show you what that looks like. So again, here, I'm just going to type in slope. I hit caps lock and intercept. Actually, let me just do it over here. Boom. Slope, intercept, and these are labels. Intercept. But again, the command is equals slope. And again, it's going to say, what are your Y values and your X values? Oh, well, here are my Ys. And you'll notice it's the exact same stuff as we did for the regression, the correlation coefficient. Nice. So I've got a slope of negative 0.14. Intercept, of course, is equal to intercept. There it is. And then my Ys. Again, click on the first one, Shift, Control, down arrow, comma, And again, I know I make this look easy, but I've been doing it for a long time. I actually took spreadsheets in high school. I took a full semester of spreadsheets in high school. So now I've actually just built a model, my model, and I'm going to have to put a little f of x or y, right? F of x equals negative 14.33 x plus 938. Roughly, I just built a linear model. Cool. Well, how do you actually get that model to work? Well, I'm going to insert a column next to the actual inches of precipitation. So I'm going to highlight that column, right-click, insert one to the left, and I'm going to put predicted. And here's how it works. And this is pretty cool. And again, part of this is how to learn spreadsheets as well. Predicted. What I'm doing in this model is I'm going to follow this form. So it's going to be equal to this cell right here, H1. What's the input value? What's the X? Well, I'm going to multiply it times by this is the input value right there, the X value, plus that one right there. And you can see I'm basically following this exact same form, and I'll get a graph of it right there, and it says 932.71. Okay, yep, I'm going to carry that all the way down. Whoa, 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 whoa. So that looks good. There was actually 1,400 inches of precipitation. I calculated it was 923. Then the next one was 717. It went up to 1,800. Weird. Now, if you have a bigger keyboard, you can type in F2, and you can see what happened here. When I copied this formula down a cell, it shifted the year correctly, but it also shifted the slope and the intercept down a cell, and I don't want it to do that. So here's what I'm going to do. I'm going to go back to my original thing and clean that out. And I'm going to put dollar signs, which mean lock the cell. So I go into that cell, I put a dollar sign in front of the H, dollar sign in front of the 1, because that's the slope. I leave the B4 alone because that's the input, the year. And then the H2, I'm also going to put dollar signs around that. Now when I can Control C, Control V, Control V, Control V, or I can grab that little corner right there and I can double click or drag it and it'll autofill it. And now what I'm doing is I've built a predicted value based on the year compared to the actual precipitation as well. So let's just review real quick. Build a function. I did it. I built a function, and I have the instructions here for linear and exponential. Plot your model by plugging in the X value into your function. Yep, I did that. How well does your model work compared to the data? Find the sum of squared errors for your model. So here's what, another little statistics thing that's really important. How well does this work? I'm going to insert one to the left. I'm going to call it error. Error squared. So if I just take, again, equal sign, actual is, in my case, column C, predicted is D, and I do that. All I'm doing here is just finding the error, actual minus predicted. And a positive number means I have under-predicted, and a negative number means I've over-predicted. But if I try to average these out or add them up, let's just add them up for fun. So right here, I'm going to put total. Let's call it total, and I'm going to go sum. So that's the command in Excel or Sheets, equals sum, parentheses, and then you have to type in the range. And here's my values. So there, you can also hold down the arrow key, you can use your mouse. Remember, when you use a formula, if you have an open parentheses, you have to have a closed parentheses. So I'm going to do that. Boom. What? It says my error is 0. Pause the video. Think about that for a second. Okay, boom, welcome back. Actually, the reason your error is 0 is because it uses the error to find the best model. So if you add up all the error, all the positives and negatives, is 0. And if you look at my picture here, this little dotted blue line is actually this model right here. 938 is that point right there. The slope is -14. it basically cuts all that data points exactly in half. So half of the values are above the line, half are below the line, which means your model error is 0, which is kind of crazy. So that's why we square the error and then we add it up. So what I'm going to do is I'm going to go back to this. I'm going to clean this out. And I'm going to put equals parentheses actual minus predicted, close parentheses, and then my caret squared. I want to square them. Boom. Now I can highlight it out. And now there's a lot of other things. And now your total is your sum of squared error. Basically, this is a way that you can compare multiple models. And you want to try to get that squared error as low as possible. There's other measures. Sometimes you take the square roots of it. You take the averages of it. We can average this number instead of total it. I mean, that's a whole nother way. But for now, I just want you to have this idea of measuring how well your data fits. Because how well does it fit? Find the sum of squared errors. Sweet. My video is now 11 minutes. Yikes. What does your model predict for a future period? So if you're using time or something else, you might predict if you're looking at maybe strength training, you know, what happens if you, I don't know, eat more calories? Can you lift more weight? It's really, that question is more up to you. But what I'm trying to say here is, hey, how can I apply my model if I put in a future period like 30 years? And now I can go over here and say, all right, what would that look like? I would predict in 30 years, oh, the snow total would be 508. That is everything for part 2 of your assignment. If you want to go into part 3 to get 100% full credit, it's going to take a little more work, a little more rinse and repeat, but I'll include that in the next video.